Welcome NEB Class 11 and 12 students. Ever wondered why things spin, roll or turn? Today we'll uncover the hidden physics behind everyday rotations. We'll break down rotational dynamics, torque, momentum and inertia, using real-life examples, not just equations. Let's dive in and see the spinning world with new eyes. Why does a ballet dancer spin faster when she folds her arms? It's all about conserving angular momentum. When her arms are out, her mass is spread out, increasing her moment of inertia. Pulling her arms in reduces that inertia, so her spin speeds up to keep angular momentum constant. It's physics in motion, graceful and precise. Why do bicycle wheels have spokes instead of being solid? Spokes keep the wheels strong and light. Less mass means lower moment of inertia, so it's easier to start, stop and ride efficiently. Spokes are a perfect blend of engineering and physics. Why is it easier to open a door from the handle than near the hinges? It's all about torque. Torque equals force times distance from the pivot. The farther from the hinges you push, the bigger the torque, making the door swing open easily. That's why handles are at the edge. Why does a gymnast tuck in during a flip? To spin faster. Curling up reduces her moment of inertia, so her angular velocity increases, just like the dancer. Before landing, she extends her body to slow down for a safe finish. Conservation of angular momentum in action. Why does a potter's wheel keep spinning after a kick? Rotational inertia. A heavy wheel resists changes in its spin, so it keeps turning until friction slowly stops it. That steady spin gives the potter time to shape the clay. Why does a rolling ball eventually stop? Friction and air resistance. Rolling friction and drag act against the ball, draining its energy and slowing it down. Real-world forces always bring motion to a halt. Why do engines use heavy flywheels? To smooth out power delivery. The flywheel's large inertia absorbs jerky bursts from the engine, releasing energy steadily. This keeps the engine running smoothly. Heavier flywheel, smoother ride. Which rolls down faster? A solid or hollow cylinder? The solid one. The hollow cylinder's mass is farther from the center, so it has more rotational inertia. More energy goes into spinning, less into moving forward. That's why it's slower down the ramp. Why do skaters spin faster when they pull in their arms? Lowering their moment of inertia speeds up their rotation. With almost no external torque on the ice, angular momentum is conserved. It's the same principle as the dancer. Physics on ice. Why is torque called the rotational equivalent of force? Force changes linear motion. Torque changes rotational motion. Newton's second law for rotation. Torque equals moment of inertia times angular acceleration. Mass becomes moment of inertia. Acceleration becomes angular acceleration. Torque is what makes things spin. We've seen how rotational dynamics shape everything from dance to engines. These aren't just exam questions. They're the keys to understanding the world. Master these concepts for your NEB exams and beyond. Stay curious, keep exploring, and see you in the next video.